Hey everybody, Dr. Phil here. This is going to be a video on introduction to business data sources. So think about like where are we getting the data from? So there's obviously the two main answers are internal, right, within the company and external outside of the firm. Um, so let's talk about internal data sources first. So an enterprise system, also sometimes called an ERP, enterprise resource planning system. Think of this as a company's interconnected information systems that connect to each other. So, accounts payable is tied to, purchasing, accounts receivable is tied to sales, so on and so forth. These are typically centralized databases. Some of the big companies that do this, of course, very expensive. Companies like SAP, Oracle, and Workday are some examples. So there's basically three components of a relational database, three basic components. So relational databases are an efficient means of storing data in one place, in one table instead of multiple places, and having the following components. So tables, data organized into sets of columns or fields, and of course rows, records. And fields, these are the columns that contain descriptive information about the observations in the table, including primary and what we call primary and foreign keys. I'll explain those a little bit here later on. And then records. These are the rows in a table. Each row or record corresponds to a unique instance of what is being described in the table. So how tables connect together in a relational database. So common fields connect individual tables to each other. So primary key would be the unique identifier. So that could be like a, tax ID number, social security, so on and so forth. Foreign key exists to create relationships or links between two different tables. So if you notice in Exhibit 4.1 here, we've got the foreign key, right? And then this is a foreign key in the transaction table, right? But if you look in the customer table, then that's the customer ID. That, of course, is the primary key, the unique identifier in the customers table. Now, as far as data sources outside of the firm goes, there's obviously a lot. Social media definitely these days, census data, small business SBA, small business administration data, publicly available data, could be financial statements of publicly traded firms, stock price data, aggregated or summarized financial data will also be available. So the four V's or the big four V's of big data. Um, so it's basically what you see on the right. So volume, velocity, variety, and veracity, right? So, as far as volume goes, we're thinking about things like how much is there, looking at click streams, logs, events, possibly speeches even. As far as velocity goes, like how quickly is it generated, the speed of generation, the rate of analysis. With respect to variety, it could be semi-structured, it could be unstructured, it could be fully structured. And then veracity, is it untrusted and is it uncleansed, which does present problems if that's the case. So for variety of data, if it's structured data, highly organized data that fit nicely in a table or database. Examples of that would be financial statements, a database of customer orders and preferences. Unstructured data is data without organizational structure. So things like blogs, tweets, pictures. And semi-structured data it basically has elements of both of the two above. And with respect to data formats, it could be text data, so things like tweets, hashtags, Word docs, for example. It could be tabular data, so think about tabular as in tables, data structured into rows and columns, so think about Microsoft Excel, for example. With regard to file formats, data is usually delivered as what we call comma-separated files, or that you've probably seen like on a lot of Excel, it'll say .csv, and that's what that stands for, comma-separated files. So .csv files store data as text, but they convert rapidly to a tabular format when they're imported into spreadsheet applications or used with programming languages. .csv files do not have the same row and column limits that Excel has, which allows .csv files to hold big data that exceed Excel's size limits. So you can see there are these benefits to these .csv files. Now, with regard to the level of aggregation, how do you want it? Do you aggregated data, which is data already processed and transformed? It's already combined in subtotals, counts, sums, or averages. And raw data, which gives the analyst the flexibility to process data as they see fit. So a little more flexibility with raw data, perhaps less so with aggregated data. With regard to data types, there's a few different types. A couple we'll mention here to start with: categorical and numerical. So categorical tend to be represented by words, such as categorizing a group of people by gender, like male, female, so on and so forth, or categorizing transaction types, so perhaps sales versus returns. Numerical is just simply numbers, right? So transaction amount, net income, age, the score on an exam. And then we have what we call nominal data. This is part of categorical data. So it's categorical data that cannot be ranked. So like, male or female, you don't rank one above the other, obviously, right? Sale or return, they don't rank one above the other. The location is sale. So we summarize these by counting and grouping them. And we may also be interested in the proportions, like, number of males versus females, for example. Ordinal data is categorical data that allows or implies ranking and sorting. So, for example, like, in a race, like, perhaps like an Olympic event, gold, silver, and bronze in an Olympic event. Survey answers, agree, indifferent, disagree, possibly transaction dates. We summarize these by counting and grouping. We may also, again, be interested in the proportions and ranking because the ordinal data is ranked. So think about like the term ordinal, like we're going to put it in an order. Easy way to remember it. Numerical data, interval data, this an equal interval between each observation, so that not only does summing the data make sense, so does multiplication and other more complex numerical calculations. So SAT scores, obviously there's the same sort of space, if you will, between each score. Same with the Fahrenheit temperature scale or the Celsius, either one. Here we summarize these by counting and grouping. We may be interested again in the proportions and also perhaps summing and averaging. Now, ratio data, this is numerical data with an equal and definitive ratio between each data point and an absolute zero, meaning an absence of, whatever you're measuring. So like height and weight, right? If it's zero height, zero weight, then obviously there is no weight and there's no height, right? Most accounting figures, sales, net income, depreciation expense, would be good examples of ratio data, as would be the Kelvin temperature scale. But of course, the Fahrenheit and the Celsius scales would not be because, 0 Fahrenheit, 0 Celsius, there's still temperature. Preparing data for analysis. So we have to ensure data quality. We've got to ensure that data types for each attribute are appropriate. We've got to validate the data for completeness and integrity. So were the data completely extracted from original source? Were any data manipulated or tampered during extraction process? And we may want to cleanse the data using things like trim and clean functions to prepare the data for analysis. We also must address missing data, and I can tell you as a researcher that often happens. When you're gathering data, you're not always fortunate enough to have every data point that you need. So step one, we're going to ensure data quality. Step two, we're going to validate. We're going to validate the data for completeness and integrity. Step three, we're going to cleanse the data. Basically, think of that as we have to make sure it fits into the format we need to be able to conduct the pertinent and appropriate analysis on it. And step four is perform. So perform the preliminary exploratory analysis. So determine the relevance of the question that you identified in the SOAR model and ensure that you have the data you need to answer your question. So regarding missing values, so wanted to circle back to that real quick. There's really a couple of things you can do. You can leave it as is. You can still run pretty much all statistical analysis, even with missing data. Of course, it lends questions to the accuracy and the credibility, the validity of the data. You can remove the records that have missing values, just take the whole thing out completely. Or what's most common is what we call impute values, which it sounds bad, but we basically guess a value. So some programs like SPSS, that's an IBM package. It's SPSS statistical package for the social sciences. We'll actually just typically do like an average value to replace those with. So there are ways around that. There's some available software tools. I won't go through all of these. There's obviously a lot here, but pretty much everybody has Microsoft Excel. You can do pretty good analysis in Excel. I will say that it's very simple to do. You can run an easy regression, maybe not a more complicated regression, but sort of a multiple regression, a simple regression, easy to do in Excel. Things like MANOVAs, ANOVAs, you can do those too. Tableau is more of a data visualization tool. And then if we just pick, say, one more, Alteryx. So Alteryx is used to manipulate and clean data in preparation for analysis. You can do some data analysis, rudimentary data analysis in Alteryx, but yeah, it's more of a program used to manipulate and clean data in preparation for analysis. All right. Thanks for watching the video, and I will see you all in a future video.